All right, section 3.6 is about mechanisms. We're going to talk a lot about mechanisms. Mechanisms show really how a reaction occurs. All right, the definition, as I have here, a detailed account of electron motion. What it does is it shows the reader, it shows somebody where the electrons are going. How are the bonds forming? How are the bonds breaking? That's what chemistry is. Chemistry is all about electron movement. All right, there are two types of mechanisms. The first one is a radical mechanism. We're not going to talk too much about this. Okay. The reason is because not many reactions go by radical, and if they do, they're very unpredictable. But basically what happens is your bond, remember your bond is two electrons, and what happens is this bond breaks in half. One electron goes to one bromine, the other electron goes to the other bromine. Notice my arrows, it's what's called a half an arrow, because it's only implying one electron, and you form bromines with unpaired electrons. That's what a radical is. Radicals are unpaired electrons, all right, and they're very high in energy and are not very stable. Okay, but we're not going to talk too much about these types of reactions. The second type, which we are going to talk about, is heterolytic cleavage or heterolytic breakage. Heterolytic cleavage. All right, this is where one atom loses the electrons and another atom gains the electrons. In the above case, nothing is gaining anything or losing anything. They're both doing exactly the same thing. But for heterolytic, one loses and one gains. So just to give you an example, let's say I have an iodide ion, and I'm reacting it with methyl bromide. I'm doing a substitution reaction, where the electrons from the iodine go to the carbon. Notice it's a double-headed arrow because we're getting two electrons, and these two electrons then go to the bromine. So we basically substituted the bromine for the iodine, and both electrons moved. So that's heterolytic. I guess you can say two electrons moving rather than just one electron moving. All right, sorry about that. Someone was at my door. The other thing is, let's talk about Lewis acids and Lewis bases, because we've talked a lot about that last chapter. So I want to, again, get back into recognizing what is a Lewis acid and what's a Lewis base. So remember, the iodine in this case is our Lewis base because it has the negative charge. Remember, things with strong negative charges are Lewis base. The methyl bromide is the Lewis acid, and in particular, it's the carbon. Why is it the carbon? Because the carbon has a partial positive charge, because your bromine technically is a little bit more electronegative, so that has the partial negative charge. So that's why your iodine is going to the carbon. Okay? Always the first step of mechanisms is to determine what is your Lewis acid and what is your Lewis base. All right? So basically, these heterolytic cleavage, I'm showing you arrows. Again, the arrows are showing a detailed account of the electron movement. Right, section 3.7 is more about mechanisms, in particular about polar reactions. That's basically implying a heterolytic reaction. But basically, what you have to remember is that your base, your Lewis base, always shares the electrons to your Lewis acid. Okay, so the negative thing always gives the electrons to the acid. So your arrows always go from base to acid. You always have to remember that. Now, one of the things is that this Lewis acid base thing confused a lot of people. It confuses students too. It's like, well, where's the acid? Where's the base? The point is, it doesn't have to be an acid base. The point is that this explains all reactions. So they decided to change the name. Rather than calling them Lewis acids and bases, they decided to give them separate names. Okay? So a Lewis base has a new name, and it's called a nucleophile. Okay? Nucleo meaning nucleus, meaning positively charged, and phile meaning loving. So this is something that really wants a positively charged molecule. All right? So nucleophile now is the term I might be using. Examples are like hydroxide, ammonia is a good A Lewis base, it's got lone pairs. So anything that has a negative charge, partial negative, we'll also see in some cases pi bonds. Things with pi bonds can act as a Lewis base. A Lewis acid, rather than calling them Lewis acids now, they are called electrophiles. All right, these are just more generic names, and these are things that are electron poor. All right, because these are partial positive or positively charged molecules. Examples would be acid, like H3O+. The methyl bromide example that we had technically is acting as a Lewis acid because your bromine is more electronegative, so your carbon has the partial positive charge to it.